sometimes when you're given a linear system of equations, it's not actually written in the standard form, in which case we have to fiddle around with the equations a little bit to get it that way. For example, if I give you this system of equations, where the first equation is 2 times quantity 2 minus x equals 3y minus 2, and then the second equation is 3x plus 9 is equal to 4 times the quantity 5 minus y. So now this doesn't look like the system of equations that you're used to seeing, but let's try using simplifying the expressions, combining like terms and distributing in order to get it to be how it should look. So first thing we should do is distribute the 2 into that difference. So the first equation is going to turn into 4 minus 2x on one side, and then 3y minus 2. The right side stays the same, and we're going to do the same thing with the right side of the second equation. That is, we're going to distribute the 4 into that difference. So for the second equation, the left side stays the same, 3x plus 9, and then equals 20 minus 4y. So now the system looks a little bit more normal, but remember that usually we want it to be in the form ax plus by is equal to c. So using that as our goal, as our framework, let's move all the x's and the y's to one side and all the constant terms to the other. So with that, the first equation, 2x, let's subtract a 3y from each side. So we're going to get 3y here, and then we want to move that 4 over to the other side, so we want to subtract a 4 from each side. So on the right side we're going to get minus 2 minus 4, which is minus 6. Then the second equation, we want to do the same thing. We want to have 3x, and then we want to move that 4y over by adding it to both sides. So we're going to get 3x plus 4y, and then we want the constant term all on the right. So in order to do that, we subtract a 9 from each side. So 20 minus 9, it's going to be 11. So this is our new system of equations that we've managed to reduce from what we originally had. And now we can solve as normal. So remember that the goal is to cancel out one of the variables by making them by making the coefficients additive inverses. So first we pick the variable to get rid of, and usually the best variable to get rid of is the one with the smallest number of coefficients, so you deal with smaller numbers, and that seems to be the x. So now we want to make the coefficients in the x opposites. So notice that if we multiply this top equation by 3, and if we multiply the bottom equation by 2, then the coefficient for the x on the top equation is going to become minus 6x, and for the bottom equation it's going to become 6x. So therefore when we add the equations together, they're going to cancel out. So let's do those operations. So let's multiply the top equation, each term, by 3. So 3 times minus 2x is going to be negative 6x. 3 times negative 3y is going to be negative 9y. And then 3 times negative 6 is going to be negative 18 for the top equation. And then the bottom equation, 2 times 3x is going to be 6x, as we said. Then 2 times 4y is going to be plus 8y. And then 2 times 11 is 22. So now, adding these two equations together, the x's are going to, when you add them up, they're going to give you 0, so they cancel out. For the y's, you're going to get minus y. And here, 22 minus 18 is 4. So we have negative y is equal to 4, and if we divide by 1, we get y is equal to negative 4. So now we have the solution to one of the variables. But remember, this is a system of equations in two variables. That means we have to solve for both x and y. So now what we can do to solve for x is plug y is equal to -4. That's not a very good looking -4. Let's redo that. So you want to plug y is equal to -4 into one of the equations. So into either of the original equations. And since we didn't do anything different, we didn't change the equations, it suffices to use these. It suffices to use these, which were the ones we left with, as opposed to going all the way back to the beginning and using those at the top. So, using one of these two equations, it looks like the second one might be easier to deal with. So let's plug y is equal to -4 into the second equation. So we get 3x plus 4 times y, which is -4, is equal to 11. Oops. So 3x minus 16 is equal to 11. So 3x, we add 16 to both sides. That's going to give us 27. And then, which means that x is equal to 27 over 3, which is otherwise known as 9. So now we have our x and our y, and we want to write our answer in terms of the ordered pair x comma y. So what we want to say is that the solution to the system is x comma y, so 9 comma -4.